resultant of two vector. Now how to write the resultant of two vector? Now first we will discuss how to take the angle. The angle between two vector is defined as, suppose this is vector A, this is vector B. So the angle between two vectors is defined as, if I join the tail of these two vector, this is vector B, the angle between the two vector is the angle whose value lies between 0 and 180. The angle between two vector always lie between 0 and 180. So it is theta. Watch this clip. See, this is vector A, which is equal to 7 I cap plus 4. This is vector B, which is equal to 5 and 14. So how to add these two vector? First we will bring this vector A here. Then again we will bring this vector B and put it on the head of vector A. This C vector is the resultant of vector A and vector B. So this is vector A, this is vector B. So these components, this is 7, is 5. So it is equal to 12. So vector C is 12 I cap and 18 j cap. So this is the way to add the components the two. Now in the same way, this is our vector A. Suppose this is vector A, this is vector B. Now we have to add these two vector. So I will bring this vector B from here to here. This is vector A, this is vector B. Angle between these two is theta, so this angle is theta. If I join this will give me vector C, which is equal to vector A plus vector B. So this is vector C. Now if I drop a perpendicular from here, so this length comes out to be B cos theta. It is B cos theta. This length is B sin theta. So I can say the magnitude of vector C is root over this square plus this square, because it will form a right angle triangle. So magnitude of vector C can very easily be calculated by, see this green triangle. This is actual right angle triangle. So I can say vector C is equal to A plus B cos theta ka whole square plus this B sin theta ka square, which comes out to be magnitude of vector C is root over A square plus B square plus 2AB cos theta. Now since magnitude of vector A plus B is equal to C, is magnitude of C. Now as we know, C is equal to root over A square plus B square plus 2AB cos theta. If I put theta is equal to 0, means suppose this is vector A and this is vector B. If the angle between this vector A and vector B is 0, so in that situation we can say this is vector A plus this is vector B. This is vector A plus this is vector B will give you vector C, that is equal to root over A square. The magnitude of this vector C is root over A square plus B square plus 2AB cos 0. Cos 0 is 1. So we get root over A square plus B square is A plus B. So magnitude of vector C is simply A plus mod of A plus mod of B. So this is the maximum possible value of C. Again, though these three vectors are not forming triangle, but this is called triangle law of addition of vector. So this is the maximum magnitude of vector A plus vector B. If theta is 180 degree, suppose this is vector A and this is vector B. As we know, these two vectors are opposite. So if I add this vector B here, this is vector B. So the resultant is this vector C. So resultant of vector C is written as root over A square plus B square plus 2AB cos pi, and we know cos pi means cos 180 is minus 1. So this is equal to root over A square plus B square minus 2AB, which is equal to mod of A minus B, or It is mod of A minus mod of B. So the resultant is this. This is the minimum value of vector A plus B. So minimum value of minimum is mod of A minus B. It is possible when the angle between the two vector is 180 degree. Now, as we know, the magnitude of vector C, we know this is vector A, we know this is vector B, we know this vector is resultant of vector A and B. This is vector A plus vector B, which is called resultant, that is called C. We can say the magnitude of C is always less than mod of A plus B. As we have already calculated, the magnitude of C is maximum and is equal to A plus B, and the minimum value of magnitude is mod of A minus B. So the maximum value of this is A plus B and maximum minimum value of C is mod of A minus B. So we can say mod of vector A plus B always lies between mod of A minus mod of B and mod of A plus mod of vector B. Mod of this vector A plus B always lies between mod of A minus mod of B and mod of A plus mod of B.